Okay, so Friday, 5 topics of Alex are due.
Tomorrow.
That's tomorrow. You must have 5 topics done. Shh. Until you finish the whole pie. You have to keep doing 5 a week until you finish the pie. But guess what? Stop talking! Oh my gosh. Literally, I don't care about your Alex topics. You have problems with this, you come to bonus. Come to bonus. Right now, not the time to talk about it. Okay, 5 topics due tomorrow. Unless you finish the pie. The moment you finish the pie, I'll put hundreds in, the rest of Alex for 3rd quarter.
Okay.
So you could do 20 topics a week, but you have to do at least 5 minimum unless you're done with the pie. But what this forces you to do is hopefully get at least 50% on Alex. Ideally, everyone gets 100 because these are the topics that we're studying right now. So today is 6.4 and 6.5. We're doing light, right? We're going through 2 sections, but we kind of have a lot to get through. Question.
You said it before, I just don't remember. What does the Alex topics go up to in terms of the paramedics?
It's covering all of the chapter quarter 3 stuff. So it's chapter 5, 6, 7.
Okay. Some of the stuff.
So is 7?
Hold on. He's not done talking to this question.
No, it's fine. I was just saying, I don't know some of the stuff.
Right, because it's chapter 7. Yeah. You had a question, Natalie?
Yeah, there's chapter 7 on the log stuff.
Yes.
Yeah, that's it.
Yeah, well, you have to do at least 5 topics a week. So it'll force you to learn some of it before we go over it together. Therefore, you'll get a better test grade because you'll already have seen it, and so it'll be easier to do. All right, so 6.4, nth roots. So 6.3, we went over square roots. So those were the 2nd root. You have a question?
You have extra coffee in the shop.
I gave you an extra last time.
I know, I cleaned out my bag yesterday.
You have to clean out your math notes too.
Since a trend.
What? No, stop.
I made one extra copy. I'll make one more for you right now, but then that's it. You gotta have it, okay?
Yeah, I won't.
That is just don't do that.
Come on. Okay. So, nth roots. Here we're talking about things more than just the 2nd root. So, 2nd root, throw back to last class. The 2nd root, something like the square root of x, right? Normally we just say square root x. We don't put the 2 there. If it's not a number, we assume it's the 2nd root, a square root. Now, if we deal with a 3rd root, something like this, the cube root of x, what we're looking for is what number times itself 3 times will be x. So, for example, if I have the cube root of 8, what times itself 3 times is 8? So 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. If I have something like the 4th root, right? The 4th root of 81. Something times itself 4 times is going to be 81. 3 times 3 times 3 times 3. Times itself 4 times is 81. Okay, so we're good with that so far. Nth roots, it's just more than 2nd root. Okay. Now, you definitely have covered this in question? You have a question?
Yeah.
Okay. So, you definitely have covered this in Algebra 1. Some of this is review, because I looked through the notes from Algebra 1b to see what you've previously learned. So, if I wanted to write the square root of x as x to some exponent, do we know what it would be? Square root of x is the same thing as x to the
First power.
1/2. Yes. So the square root of x is the same thing as saying x to the 1/2 power. Literally, whatever number is here is what number goes on the bottom of the fraction in your exponent. Let's try another one. What if I have the cube root of x? What would this be? X to the 1/3. Let's try a hard one. 7th root of x. X to the 1/7. Look at you go. Look at you go.
What's a 707?
Okay. Ready for a trick play? I just told you it's a trick play. Uh-oh. So, What if I have something like the cube root of x squared? Ooh, what's this gonna be?
X to 150.
Wouldn't it be 2x
No.
to Dude, I put added.
Wouldn't it be 2 1/3?
So, okay. So it's kind of weird the way we're approaching this. I'm trying to I'm more or less covering 3 sections all together. Because in order to do this section, you really have to know the section 6. So 4, 5, and 6 are all pretty similar together, right? I'm sorry. Yeah, 4, 5, and 6 are all really similar together. So before, right, whatever root this is, the second root, you go, oh, on the bottom of your exponent, you make it into fraction. The third root, oh, you just take whatever your exponent was, see really it was 1, and put on the bottom. Put it below whatever the exponent here was. So this is going to be, we put the 3 below the 2, so it'd be x to the 2/3 power. Okay.
I thought it was.
Okay. So, cool. This is what I already talked about. N is the index. That's why we say nth root. Like, do I want the second root, the square root, the third root, the cube root, fourth root, quadric root? What? Yeah. This guy? This last one? It's coming. Okay. Cool. So we have a radical, and then the radicand is what's inside. So notice the principal roots. So after I explain this, I'm gonna give you guys the problem to do, and I'm gonna go get the notes for Jordan. Principal roots. Sometimes we have more than one root. All right. So if I say, what is the square root of 4? What do you say?
2.
2. But if I ask you, x squared is equal to 4, what is x equal to?
2.
Well, if you are putting the square root there, you have to include plus or minus. That's good. If I ask you, gotta pull it together. If I ask you to evaluate the square root and it's written for you, you just put the principal root, just the positive. Versus if you're solving, notice in the blue I put the square root there to solve, you have to include the plus or minus. Okay, that's all the principal is saying, right? So 9 has 2 roots, -3 and 3, blah, blah, blah. But if I say square root 9, you only put the positive one. So I want you to try out the first 2 examples, right? Square root 64 and cube root -27, and I'll be right back. Get the notes for Jordan. Try these 2 problems out. If you want, 2 people can do it on the board. Just like, bring it back.
I'll do it.
I mean, that's not.
It's
It's 8.
Someone explain this.
No, it's not.
It's negative 8 times negative
64 done.
$1. That's what I said.
No, you didn't. You heard the coming.
Yeah.
Wait, how do we do
Negative
this? The first time
27
I've never
to
done
the
this.
1/3. Negative 27 to the 1/3.
No, it's
Cooper.
Yeah.
But you were such a me.
Look. You put the 3 and then under the 1. It's negative 27 to the 1/3.
Alright.
It's
Alright, no one's on the board, so I'm just gonna move on.
Oh, can I do that? I thought we were going to Can I do it?
No,
Can I do B?
I said when I get back, I want people on the board. No one was on the board, so we're going on. Alright, so, root 64. What's the square root of 64?
8.
8. Wonderful. Cube root
to the 1/3.
of -27.
Wow. What did I say?
3. I love. Huh?
Wow. I was right. Wow.
If you take -3 times -3, you get +9. +9 times -3 is -27. There's only one answer here. So you can have a negative under an odd root, under a cube, right? 3rd root, 5th root, 7th root, but you can't have a negative under an even root, like a square root or a 4th root. Caitlin, question?
So for the answer, will we just write -3? Or do
I boxed answers.
No, but to get credit, do we have to write it
Well, I'm not going to give you a problem this easy. This is trying to warm you guys up to really understand what we're doing. This is what you learned in Algebra 1. I'm gonna give you algebra 2 questions this time. So, like D would be like the easiest problem I could give you on a test. Question, Jordan.
Is negative 3 the same thing as negative 27 1/3?
Okay, so negative 27 to the 1/3 power, it is. It is.
Wait, so if we put
Yeah.
negative 27 to 1/3.
So
No, because you gotta simplify it.
Do it then.
You gotta simplify it. This would be an intermediate step. This would be an intermediate step. Okay. So, this was a good transition into how I'm going to solve this next one. Do we know what the answer should be for this one? What is it? What do we know the answer should be? Plus or minus 4x squared. Okay, now I'm going to introduce you to a method of solving that we're going to use for a lot of the class. Now, the reason I'm doing it for this problem is because you know what the answer should be, right? You know what the answer should be. I'm going to prove it to you a different method because you won't always be able to look at the problem and know what the answer should be. So, the first thing I'm going to do is I'm going to rewrite this as square root 16 times the square root of x to the 4th. Because if you have something being multiplied under a radical, it's the exact same thing as if you would just have radical of the first times radical of the second. Now, do we know what the square root of 16 is? 4. Okay. Let's see. It was Jordan, this last problem. I could take square root of x to the 4th and rewrite it as x to the 4th to the 1/2 power. Thinking back to chapter 5, rules of exponents. When I have an exponent, 4 to another exponent, 1/2, what do I do with my exponents? Multiply. What is half of 4? 2. There you go. So I'm rewriting using the exponents. If you're saying, what? This is what we're going to be doing for the next like 30 minutes. Where we're going to get successively harder and harder. Okay.
So our answer is plus or minus 4 to the x squared.
Plus or minus 4x squared.
4 to the x squared.
Okay. All right, let's keep going. Questions? Raise your hand. I'll give 3 seconds. No one's raising their hand. All right, we're moving on. What I would like to do is I'm going to write this, but instead of having a square root, I'm going to write it as y plus 7 to the 16th all to the 1/2 power. So instead of writing this square root here, I'm going to have to the 1/2. I'm sorry, there's a lot of talking. I'll wait a sec. Okay, question, Jordan, and then Felix.
Can you just take out the square root and make it 15?
No, because you're not subtracting. So you have an exponent to an exponent. You have to multiply the exponents. So you get negative y plus 7 to the 8.
I mean, not make it 15. I meant 8. You divide.
You're dividing by 2.
Yeah. Yes.
No. That's as simplified as it can be. No, because there's nothing else I can do.
Wait, is that completely simplified?
I boxed it. That's the answer.
But then why is the
I'm not sure how or why you put to 1/2.
Okay, ready? Let's go through this. Let's go through it. Let's do it. Okay, if I say square root of y, this is literally just y to the 1/2 power. We're good. Okay. If I say square root of y plus 7, this is just going to be y plus 7 to the 1/2 power. Good so far? Because 1/2, because it's the square root. So it's 1 over 2.
1 over 2.
Okay. So we're good so far?
Oh, okay.
Right. So I'm going to go over other roots. Just like that. But I want to have you understand the rules of exponents when I have an exponent to an exponent. Are we good with the second line?
Yeah.
Okay. Now imagine instead of having just y plus 7, I have y plus 7 to the 16th. Okay. This is the exact same thing as saying y plus 7 to the 16th all to the 1/2 power. And now that I have an exponent to an exponent, I must multiply these together. Half of 16, 8. So my answer would just be the y plus 7 to the 8 power. And the reason I have a negative in front, that's Like I have a negative in front in the problem when given to you. That's why I have a negative out front at the answer. We're like literally, are you ready? I know this is hard, but that's why we have lots of practice. And tomorrow's lesson, it's kind of a continuation of just like more practice. I kind of secretly already taught you tomorrow's lesson in order to do today's like successfully. So more or less it's just 2 days of doing the same stuff. Lots of practice. Okay, so we also want to learn how to do approximation. So I'm going to teach you not only how to do square roots, but cube roots, quad roots in your calculator. So although you didn't need a hat today, you do need your calculator so you can practice, because this is not something I will tell you when you're taking your test.
Do we need hats? Damn. What? Really?
Okay. So this next part is that yours? Okay, cool. You're using your calculator to approximate nth roots. So we're gonna go through how to do these. Do you know how to take the square root of 58?
Yeah.
Okay, go ahead, put it in your calculator. I will show you.
Alright.
I'm pulling up my calculator.
7.61577.
So if you push control and then x squared, you get the square root.
Yeah.
Then you just put 58 inside. Wonderful. But what is it asking us to round to? 3 decimal places.
So 616.
So 7.616. 3 decimal places. I see you, Jordan. That's good.
Yeah.
3 decimal places. 3.
He's making me look
Don't.
I'm just getting all the answers right.
Okay. If I ask you, ready for this? If I ask you for the nearest whole number, what would it? Shh, I'm gonna wait till we're quiet. Till we're quiet. Because this is something that I take points off of, rounding. You're supposed to learn rounding when you're in elementary school. I need to teach you rounding right now. So, nearest whole number, 8. To the 10th place, 7.6. To 1 decimal place, 7.6. To 2 decimal places, 7.62. Because you see a 5, you round up.
Yeah.
You see the 1, you stay down. To nearest 100. 0.62. 100 is 2 places. 100 is 2 places. 7.62. Here is specified 3 decimal places. So you go to 1, 2. Okay, I have a 5 here. You look. Do I round the 5 up to a 6 or leave it? Round to it up. Round up. If you have questions on rounding, send me out the bonus. Let's do it. Literally had 1 person at bonus today. It was wonderful. She was taking a test. Cool. So I just ate my seaweed. Let's go to B.
You ate what?
I had seaweed.
Oh, I thought you said you ate it.
I ate my seaweed.
Yeah, I know.
Okay. Now I do negative root 76. So I put the negative button. Don't put the subtract. Put the negative button.
76.
And then control x squared 76.
Negative 8.718.
Negative 8.718. Perfect. Okay, that was a little warm up, reminding you how to do square roots in your calculator. Now we're going to do something else. A 5th root. Now this is a little tricky. This is tricky. So to the left, yes. Control the arrow up. Look at the board if you don't know where I'm looking. It's 2 buttons left of the 4. And you see how you can choose what root you want. So you put a 5 in, so that way I can have a 5th root. And then you put in negative 43.
Negative 2.12.
Negative 43. So this is negative 2.122.
inside the radical.
Huh? Arrow over.
Oh, no way.
Okay, I'm teaching you how to do it now, so I'm expecting you to know how to do it. Now, there are questions where it's like, use your calculator to approximate. In class, I demonstrate the amount of work I want you to show. This is great. You're using your calculator. This problem, there's no partial credit. It's either right or wrong. It's a calculator skill question. Either you know how to do it or you don't. You either know how to round or you don't. So there's no partial credit, so you don't have to show work, because literally, did you do the calculation right or not? This one, 4th root of 71. So I go control, arrow key. I put a 4. I push the arrow button over. And now I want to do 71. 2.903. 2.903. Wonderful. Okay, went over calculator skills. So the next one, I think, okay. So then there's like more example problems where we'll probably come back and do a few of these later. I want you, let's do number 3. This is the next page, the bottom of page 10. Sorry, bottom of page 10. We're going to do number 3. Because I'm trying to work you up to now other roots. And then the next section is what if it doesn't go evenly and we have remainder, right? So gradually walking you into the ocean by Santa Monica. I'm not pushing you off a 100-foot cliff in Oregon. Trying to gradually lead you into this, okay? So the first thing I'm going to do is I'm going to rewrite this. Instead of saying square root of 144 times p to the 6, I'll say square root of 144 times square root of p to the 6. So I know you guys have done this before, but hopefully if you don't remember, you get all the cobwebs off and you'll be successful. This is definitely some of the harder things that people struggled with last year was this next coming section. Okay, what is the square root of 144? 12. Okay, let me take a little aside here. Instead of saying square root of p to the 6, I'll say p to the 6 to the 1/2 power. So this is p cubed. So 12 p cubed. See, you guys got this. You got this. You got this. This is it. This is the answer. This is a very short problem. We're at more practice. You have to. You got to do your homework. What? What? Okay. All right. Let's do number 5. We're doing number 5 on the top of the next page. Number 5. Notice this is not a square root. Yes. Yeah, that's fine. What?
There's a bathroom bath though.
She's a.
No, I'm kidding.
It's fine. She was a person. She was a whatever follower.
There's no way to do that without a calculator.
I'll show you. Yeah, well, you should sign up to be one.
To go to the bathroom. Funny, they don't have one.
So instead of saying 5th root of 243 p to the 10th, I split it up.
So wait, 243, you just
So-
find out what's 243 divided by 5.
Not divide by 5.
So the
5th root. I just showed you how to do it in your calculator.
And then is it p to the 10th times 1 over 5? With, to
Times
power
1/5.
1 over 5? Okay.
So,
3 of p to the 5th.
so this right here is p to the 10th to the 1/5 power. And what is
1/5.
10 divided by 5?
It's 2.
Is 2.
B squared.
Yes. Well, I knew that 3 to the 5th is 243. That's probably not a common fact. So if you go back to your calculator and you put in 243, right, 5th root, you get exactly 3. Now the issue is, what if it doesn't go evenly? So what you could do is a prime factorization. 3 plus 4 is 6, plus 3 is 9. Okay, if you add up all the digits, and the sum is divisible by 3, then you know the original number is 3, right? Rules of division. So this is 3 times 81. Oh, you know 81 is 9 times 9. Yeah. So if you do prime factorization, you see, oh, I'm looking for a 5th root, so I'm looking for a number that's repeated 5 times. Oh, perfect. Yes.
Why would you need to do that if you have a calculator?
Because the next section, it doesn't always go evenly. I don't give you something evenly. I might give you a number that doesn't have a perfect fifth root.
Okay.
And we don't want decimals.
Oh.
So far I've given you nice numbers, getting used to it, and then I'll like gradually throw in some hooks at you. Okay, Jacob? Today, no. Today, no. We're doing 4.5, yeah, 6.4 and 6.5. According to the board, you read it as you walk in. Okay. We're going to do number 6 now. Number 6. Number 5 was to say, hey, let's do something without square roots. Number 6 is, wait, we have more than one variable. Let's see what happens. Give it a shot on your paper, and then we're going to go over it together. On your paper, we're going. On your paper, let's go. Question. No, I'm going through. We have another lesson to do. Got another lesson to do. What?
Whoa.
You need to do it.
We have to do that.
Can I do it on the board?
Okay, here's the deal. I'm trying to teach you the method, so when we go to harder problems, you can follow the method and be successful.
No, I understand the method. I'm just curious, like, in this type of problem, what type of
What? Because it doesn't always go evenly. Here, 6 does. 6 divided by 3 is 2. 3 divided by 3, 9 divided by 3 is 3. But what if I give you m to the 7 instead?
No.
Yeah, so having this method, like, I don't want you guys to remember like 50 different things. Like, if you just have the same thing over and over again, it's easier to remember. Are you touching her? Quit touching people. I should go back through the screencast, see how many times I tell Felix to quit touching people. Guarantee it's probably more than 10 this semester, and I've been screencasting every semester, every one. Yes.
Do we have to do that tree thing every time? What?
No, because I don't have a number here. It's only when you have numbers, like a coefficient.
But if I have a number, do I have to do the tree thing, or can I use a calculator?
Is it negative m squared?
I answered this question already. I already answered this question in detail. So, ideally, okay, A, your phone should be over there. I see people with phones. I'm not going to interrupt you. I'm just going to mark you down. B, you got to listen. You guys got to quit chit-chatting because I already answered questions you keep asking. So, the tree thing. Now, I've been giving you numbers that work perfectly. But the next section, I will give you numbers that don't work perfectly. And you have to have exact answers. So you'd have to say like, 2 root 3. You can't just say, 3.8, blah, blah, blah. No decimals. You have to be exact. Which is why I wanted to like kind of introduce you to the tree thing. So that way, prime factorization, we can use it later to simplify. Yes, done. No, I'm going, we have another lesson to do. I have to keep, I got to keep stopping, repeating the same things. Okay.
Yeah, I know it.
Cool. Okay, so we're going to go through 6.5.
That's what I got.
6.5. So notice if you have more than one variable, you just split it individually and you see variable by variable.
Now, why is it?
Okay, Natalie, raise your hand.
With like 21 when if they're in parentheses.
21. Well, because you could solve this first and then distribute it out.
Why is this?
We can go back to that like tomorrow. Remind me to go back to that one. But I'm going to go to 6.5. So notice 6.4 and 6.5 assignment. It's one assignment because it's 1 day of lesson. 6.5 is operations with radical expressions. So I already kind of went over this, right? If I say square root of 2 times square root of 8, this is the same thing as saying square root of 2 times 8. What's 2 times 8?
16.
16 and square root 16? 4. So if you have a square root, you can break it down into 2 of its factors being multiplied together. That's the deal, right? As long as it's the same index of root. So if you have a cube root times a cube root, you can multiply what's ever under the cube roots. If you have a square root being multiplied by a square root, you can multiply what's ever under the square root. So this is where we start getting harder. Next level. So we need to simplify this. So the first thing I'm going to do is break it up. I'm going to write this as square root of 12 times square root of c to the 6 times the square root of d cubed.
Okay.
Okay, so let's go step by step. What is the square root of 12? It's not a whole number.
3.4641.
2.
Right, so it has decimal. No use. We can't have
3,
decimals.
2, and 2.
What?
3 and 2 and 2.
So he's talking about the prime factorization.
Yeah.
So I have 12. 12 is 4 times 3. And 4 is just 2 times 2. So wait, we're looking for a square root. Square is an index of what? Square is index of 2. 2. So what factor is repeating twice?
2.
2. The factor repeating twice is 2. So this is going to be 2 root 3. Another way of doing it. Ready? Another way of saying this. Square root 12 is the same thing as saying square root 4 times square root of 3. 4 times 3 is 12. Yeah. What's the square root of 4?
2.
2. So this is 2 root 3.
Okay.
Okay. Let's deal with the square root of c to the 6.
Cube.
So this is c to the 6 to the 1/2. So half of 6 is 3.
2.
C cubed. Question? Who question? Do you have a question? No. Yeah?
I forgot what the number's called. What's the little number on top of the B? What?
The index, like right
Yeah.
here? The index.
Can you have an index?
That's
on
you can have a
on
negative
root?
index. You can have a negative index.
No. Can you have a? Can you have an index on a number like 2 rad 3?
What? There's an index right here. This is a second. Secretly. Like, I'm starting you with the square root, right? Because now I'm like, hey, let's introduce things that don't go evenly, square root, and then we'll go through things that don't go evenly with other roots. Ah, okay. Really trying to slowly, right? Bite-sized pieces.
Yeah.
Do you remember the best way to eat an elephant?
Bite size.
One bite at a time. One bite at a time.
Oh my god.
Okay, it's a saying. It's a saying. No, I don't care. I don't care. Okay.
Whoa.
This is the hardest part of the question. Are we ready?
We're so
Just make it a.
I'm waiting. 1, 2. Who's talking? When I get to 3, I'm writing down who's talking. 4, 5. Okay. I apologize. I need to watch some YouTube videos on kindergarten classroom management so I can apply it for you. Because we got to keep it together. Okay, we got to keep it together.
Okay.
I want you to be successful, and I'm trying to get through small examples. Really, drill it into your brain. Jacob, I swear to God, you gotta tone it down. You're sassy right now, sassafras, gotta tone it down. I just want you to be slightly fizzy, not super sassy, okay? Just slightly. Just knock it down a little. Okay, so I have d cubed to the 1/2 power. Ooh, when I want to...
1.5.
So this is the same thing as saying d to the 3/2. Now this is the hardest part. If you don't pay attention, you're going to be like, what the heck? And it's not going to be a fun rest of the day. You have to pay attention. This is the hardest part of the whole lesson.
What? Sorry. Is it like... Yeah.
Kleenexes?
Yeah. Oh, I'm sorry. I was blanking on the word.
Wow!
Okay.
That was a good pass.
Thanks.
I'll admit. I'm sorry. I was blanking on the word. It's okay.
As long as you throw away your trash and don't make a huge mess. Okay. D to the 3/2 power. D to the 3/2 power. What is another way of saying this? How many times can 2 go into 3? 1 with 1 left over. This is 1.5. You'll see why I'm not using decimal. You'll see. 1 and 1/2.
Do you always have to...
Okay, hold on. I will take questions, but you have to raise your hand first, and I'm not done talking. I guarantee I'm going to answer half of your little questions as I'm going through the lesson. Okay, we're going to go over this. So imagine that I had, what is x times x squared? What is this equal to?
X cubed.
Right, because 1 plus 2 is 3, x cubed. Okay, what if I change the problem a little bit? Okay, what if I change the problem? What if I have x to the 1/2 times x to the first power?
X to the 1.5.
Yeah, this is x to the 1.5. Wait, this is a way I could split it. Instead of saying d to the 1.5, I could say d to the first times d to the half. Yes, this is why I didn't want decimal. This is why I didn't want decimal. I'm trying to show you how to do this.
Even if you got decimal, you can split it, okay?
So overall, let's put this all together. Let's put it all together. So I have 2 root 3 times c cubed times d to 1/2. Wait, d to the 1/2, what's that equal? What's the same thing as saying? D square root of d.
Yeah.
Okay.
Shouldn't it just be D squared?
No. Because I want to put everything that doesn't have a radical in front of it under 3d.
That was honestly not that bad.
Okay.
Why did you use?
Because
it's 1 and 1/2 and you could.
I had d the first and d to the 1/2.
Because you can't write it like that. Not simplified. Yeah, see?
Because d to the 1/2 is the same thing as saying, oh, d to the first times d to the half. Because you add the exponent, so you'll add it to have 1/2. So you're using the rules of exponents, but going the opposite way. Instead of combining, splitting it out. So the reason I'm having you do this, hold on. I said you raise your hand, ask me questions after I'm done explaining. Literally, I don't know what your problem is today, guys. Not done explaining. So if you have something under a radical still at the end, so notice this is under a radical, this is technically under a radical, put those back together under a radical. Notice I did not give you something that was a perfect square this time. Now do we have questions? Because we're going to go over another example. Jacob.
So confused. Why can't you just write it like that?
As what?
Like D for like the way it's written like that.
D to the first times D to the 1/2?
No.
This is the same thing as saying, d to the 1/2. If you go that way. Or you could say this is equal to d times square root d, because so one. No, not at all.
He just wants to know why you have to change it from D1
You said
1/2.
it's the same thing as D1.5. Then why can't you write it like that?
You can't have fractions in your exponents.
See?
You have to convert back from fraction d to the 1/2 to the square root radical.
Yeah, that makes more sense.
Okay.
Sorry, I was like,
It's fine. It's fine. I don't think you guys have done stuff like this as hard before.
I don't even remember doing anything like this.
I'm not gonna lie. I took some notes straight from Algebra 1B. So,
I was in Algebra 1A.
if you did 1A, you did 1B.
Well, what if I was just in regular algebra?
Then you covered this more in depth than 1B. So, got him. You played yourself. Okay.
I was done.
Were you in Algebra 1?
We were in the 1 year class.
We were in Miss Rogers' class.
So you're in Algebra 1. So you actually went over more of this than 1B. So.
That's probably why I know it.
Okay, let's keep going. So I'm going to write this as cube root 27 times the cube root of y to the 4 times the cube root of z to the 7 power. Okay. So, right, this one, y to the 4th times, let's see, to the 1/3 power. This is just going to be z to the 7th to the 1/3 power, and then the cube root of 27 is just 3. That's nice. I gave you a nice number this time. Okay. So I have 3, y to the 4/3, z to the 7/3. I'm going to pause here. So I'm trying to show you a a simple way to defeat the tricky nonsense that could happen. So, for example, if I have z to the 7/3, how many times can 3 go into 7 evenly? Twice. And how much is left over?
1.
How about y to the 4/3? How many times can 3 go into 4? Once. And how much left over? 1/3. Right? 1 and 1/3. One's left over, so it's 1/3. So altogether, my answer will be 3y z squared times the cube root of yz. Now, this part right here comes from the fact that I have a fraction as an exponent. This is It is complicated. Welcome to Algebra 2. Welcome.
This is not algebra 2, this is intermediate.
I know, you're right. I did cut out a lot. This is why it's light. It's 6.4, 6.5, light.
What does it feel like to just look at a math level and know exactly how to do it? Every time. Isn't that wonderful?
Yeah.
Trying to trick you.
You think when you want
I don't. What do you want from me, Caitlin? I sympathize with you. I am trying to break it down as much as possible for you guys.
This is all on screencast, so poor person that's
It
gonna be
is.
laughing.
Yeah, poor Carly and Adi and Ruby.
Hey guys, what up?
Okay. Questions over this one? We're doing 6.6 tomorrow, which is very similar.
I don't know if I'm.
It's very similar to this. What will you do?
Does it just get
I have a
harder?
doctor's appointment.
Okay. Nope, probably not. And approved? It's probably not approved. All right, let's go on. Quotient properties of radicals. Shh. So, do you remember in chapter 5? I'll wait. Hold it in, okay? Hold in your thoughts and opinions you want to express verbally out loud. So, remember in chapter 5? Remember in chapter 5 when I'd have like xy over like x squared z, and then I put everything to the second power? Right? And I put everything to the second power. What would you do with that power?
You multiply it.
You distribute it to both the top and bottom, and you multiply it to the current exponents. Okay, now imagine here. I know that this whole radical right here, this is the same thing as saying y to the 8 over 9x. And this is all to what exponent? To the 1/2. This is all to the 1/2. This is all to 1/2. So I can instead say, okay, let's split it and have y to the 8 to the 1/2 power over 9x to the 1/2 power. And I can actually split this bottom one further. I could have 9 to the 1/2 times x to the 1/2. Wait, 9 to the 1/2, that's just the square root of 9. What's the square root of 9? 3. Okay. So I have 3. Well, x to 1/2 I can't change, so I just leave that as square root x. And what's half of 8? 4. And this is the total answer.
Wait. So,
Oh, wait, you have to put it back at the line.
How is it?
Look, I look at people who don't look at me, and then when they turn around, we make eye contact. Yeah, because you literally turn all the way around. Okay. All right. You ready? What's wrong? Yes.
When would you use this in real life?
Cool.
You got you on that one. That's an
No, I'm like being serious.
So having the ability to control your impulses and listen, that's very real. It's a good way to get subordination and get kicked out of a job if you guys act like a fool in front of your boss. Oh, I fully know what he means.
Oh, okay.
I 100% know what he means. Also, it's kind of a jerk move to ask that in the middle of class, just FYI. Also, the skills you learn from doing this, you're not even listening, I'm talking to you. The skills you learn from not giving up, critically thinking, being able to follow a method, that's what you'll use. You need to build tenacity and character to actually persevere when you hit a roadblock instead of just sitting down crying and not doing work. Yeah. The ability to critically think and break things down into the basics is a useful skill. Now, this one you may not ever use taking a square root and radical function. But what you will use is exponential functions, which is the next chapter. What you will use is knowing how to balance your checkbook, so you have to know how to add and subtract. And you
Okay, can we just...
did you though?
Can we
Did
finish
you? Do you want to be real here? Probably not. Okay, let's keep going. Let's keep going. We're not gonna do this problem. We're gonna go on. So, example 3, simplify. So, Very first thing we talked about in this section, if you have the same root, okay, who's talking?
What?
Okay. Okay. So if you have the same root, the same index, you can multiply the things that are under them. You can multiply the things that are under them. So if I take 100 and times 10, that would be 1,000. What is a squared times a? A to the third. And then I still have this 5 out front. Okay. Now this is what we do. We combined it. Now what we can do is break it down. So I have the cube root of 1,000 times the cube root of a cubed. What is a cubed to the 1/3 power? What is 1/3 of 3? 1. What times itself 3 times is 1,000? 10. So literally, you ready for a shortcut? 10 to the 4th power is going to be a 1 followed by 4 zeros. 10 to the 100 power is going to be 1 followed by 100 zeros. The number of zeros is what power of 10 you have.
Yeah, I know.
There you go. You're a lot of zeros. All right.
He's crying.
I don't care. I care, but not right
That
now.
was hard.
Yes. We literally have 13 minutes left. Okay. Okay, then go. All right. Questions over this one? Let's go to B.
Wait. Can you go over the shortcut again?
10 to the 10 squared is a 1 followed by 2 zeros.
Yeah.
Okay. 10 to the 6th power is a 1 followed by 1, 2, 3, 4, 5, 6 zeros. That's it. That's the shortcut.
Yep.
I don't know what more you want. Okay.
Oh, I get it.
What do you guys even want from me? Okay. Let's do the next one. I have these coefficients. Gotta multiply them. 6 times 4 is 24.
24.
And then this is going to be the square root of, okay, we gotta combine things that are inside.
16.
2 times 8 is 16.
C4.
C the 4.
D8.
D the 8. Good.
And then you do it.
And then I can separate them. So 24 times root 16 times root of C to the 4 times root of D to the 8. So this is 24 times 4 times C squared times D to the 4. So 96 times C squared D to the 4.
These are easy numbers.
They are. I picked nice and easy numbers for you.
Thank you.
It's what? No. I'm literally just introducing the concepts to you right now.
Yeah, I know.
Just making sure.
Okay. Example 4.
Wait, hold on.
What? Okay. Example 4. What?
Why are you multiplying 24 by 4?
Because the
Oh,
starters
yeah, yeah.
sorry.
It took me a minute to figure that out too, and then I realized.
Context, yeah. Okay, so if I would have something like 4x plus 2x, can you combine those?
Yeah.
Yes. Okay. What if I said 4 root 2 plus 2 root 2? What is this?
Oh, that is
6 root 2. Okay. That's the basics of this next part. It's the basics of this next part. So we need to have it be, we need to simplify the radicals. So we have to take prime factorization. So I'll take, yes, 8 and break it down into 4 times 2. So the square root of 8 is going to be the same thing as square root 4 times square root 2, aka 2 root 2. So I have 4 times 2 root 2. The parentheses will help you out.
5 root 2.
Because this is not 42 root 2. It's not 6. You have to multiply them. So this will be 8 root 2. All right, let's do prime factorization for 50.
5 root 2.
So 50 is just 25 times 2. So square root 25 times square root 2 is 5 root 2. What is 8 plus 15? So 23 root 2. There you go. Let's try the next one.
I almost lit.
Yeah, try the next one. See if they all are the same radical and combine them.
I don't see the next one.
B, right here. B, if you're following along your notes, it's right next to it.
Yes, I do, Jacob.
I'm not going to print you notes unless you follow along.
Okay.
You need to follow along, because if you don't have notes, you lose participation points.
What page are you on? Thank you, done. Oh.
So we have all the same radical here. So we can easily combine them. 9 plus 8 is 17. 17 minus 20 is negative 3. So this is going to be negative 3 root 5.
You're so good at this.
How'd you get negative 20?
Negative 5 times 4 is 20. Negative 5 times 4 is negative 20.
I got negative. Yeah, me too.
So here, did you get 4 root 5 for
Isn't
80?
it 2 root 9?
Oh, 2 and 5.
It's 4 root 5
Oh, 'cause I
times
got-
5.
I got 2. I got 4, 2.
What? 4 2
Oh,
is 4.
yeah.
Yeah, same.
So idea is, when you do prime factorization, if you can find the perfect square, it will help you. Like I stopped, and I was like, oh, 9 times root 5. 80, I was like, okay, 4 and 20, 4 and 5. Oh, 4 times 4 is 16, so 16 root 5. 16 is a perfect square. 4 root 5.
I just forgot to do that.
Alright, ready for more examples?
Yeah.
We got 6 more minutes, we can go through more examples.
That made sense. I forgot to get the 6.
Okay. Let's go over. Do you want to do problems from the first section or this section? Which do you want to do?
Surprises.
Okay. Let's do number 2 below, which is page 15.
Page 15.
Number 2, study guide.
Alright. We go.
Yep. I want you guys to try it, and I'll do it on the board. See if you can do this one yourself without looking at my answers. This one's significantly harder. So now that I've done it, I will come up and explain it. Hopefully you guys had a good shot of trying it. This is more the level of like what I'm going to be asking you. Yep. It is. I tried to warn you guys. I tried to gradually bring you in, showing you different tools because you have a full tool set to do this, right? Prime, factorization, knowing, exponents, rules of exponents. Question? Okay, so the first thing we do, right? All three of these things we multiply together, so I break it up and okay, fourth root of each of them. I took 32 first. Now, the fourth root of 32 is going to be some number with a decimal place. We don't want that. So I took prime factorization. Instead of saying 32, I wrote it as 2 to the 5th. 2 to the 5th, 2 to the 1/4 is just to the 5/4. So I do it as we did before, right? So this is 2 to the 1 and 1/4.
Why can't you just say it was 8?
What? It's not. It's not 4 times 8 is 32. What times itself 4 times is 32? Fourth root. Huh?
No,
8 times 8 times 8 times 8?
that's not 32, that's not.
Oh.
It's not. I know.
9 times 1/4 is 9/4. So that is 2 and 1/4. Splitting it up this way, if it's a whole number, it goes outside the radical. If it's, and then whatever this is, gives you, it'll be inside the radical. So if you have a fraction left over, it's inside the radical. And then lastly, b to the 20th goes evenly, right? 20 times 1/4, 25 by 4 is 5.
5.
How do we feel about this one?
Better than what we started.
So next class, just to give you a heads up, tomorrow we're going to be going over rational exponents, which we went over in depth today. So tomorrow, when you come to class, as soon as we finish 6.6, we'll come back and do more examples from this section. Okay.